my Nvidia Jetson. Actually, this thing cost me a $1,000, so I should call it a server, right? Not a little toy. um, so I went extreme. But this one has a 16 gigs GPU, Nvidia GPU, uh, Tegra system, I think it's called NX or Ring NX. And so far I was able to install it. Had problems installing Linux Jetpack. If you wanna have one of these, they give you the Linux image. You have to flash it into the SSD drive. So I cannot turn it around, but the SSD that came was 128 gigs, and then after downloading a few images, machine model images, I ran out of this space. So I bought one that is 256 gigs, and I was able to install it behind. So I got this one. So I don't know how to show it. I got this one. It's a 2280. It means the size. And I got 256 gigs. These things are super cheap compared like a few years ago. So this space and memory, like, they're super cheap. What is expensive today, I think, is GPUs. This is the one that came with the Nvidia. This is a 128, so it's in the bottom side. And it came in a box. I just took it out because I put in the hard drive, but it came with a nice box enclosure. This is the enclosure. It's hard to see from there, but yeah, it came with a server enclosure, like a little. It looks like a little nook in there. And the CPU is ARM. The thing that I was, let me switch over to the setup. I did the same setup as before for the Raspberry Pi. I don't know if people can see this, but I created a repo, and one of the first things I found that was kind of like, it's still a problem, is running workloads inside a GPU, and actually like getting to get the GPU. So all the examples online to validate that the GPU is working is they tell you to run this Nvidia SMI. And I think I wasted a full day figuring out like why this was not working. And the reason is because this Nvidia SMI, it looks in the PCI bus to look for the GPU. And this is not the tool. If you have a Jetson, you should not be using this tool to check on the GPU because it's not looking into the PCI. But if you want to validate if your GPU is there and it can be accessible, you can use two things. One is called Tegra stats. And if you run this, it will start giving you the information about your GPU, which is located, I think it's something here called GRD. I think it's this one. And then this one, GPU and GRD3. I think it's GRD3 give you the information. This is hard to parse. So the next tool that you can use if you have one of these embedded devices is the JTOP. So this is, you install it with Python, and then you run it. And then this one looks a little bit like HTOP. And this one is a little bit better, right? And this one also, I was kind of thinking that was not working because my GPU says 0.0. So I thought that I still needed drivers. So I was trying to debug the drivers for the GPU. And I thought that was the problem. The other thing, that if you have one of these Jetson devices, the CPU, all the CPUs, all the cores on the CPU, this one has 8. Half of them could be disabled. Actually, they came disabled. So I was only getting 4 cores, and the other 4 cores were like turned off. And I was also questioning myself. I thought I bought a core one. So it looks like the device comes with different power options. So it has a 15 watt and a 25 watt and then everything. So you have to set it to more than 15 watts of power, set it to 25 watts, and then all your cores will be enabled. Um, so for that, basically you do run a command to set the power mode. I have it in the docs, and then you have all your enables. And then for the GPU, I was wondering how to test it. So I found this GitHub repo called GPU burn, and basically is a file that will like stress a program, like run a program that will stress your GPU. Um, and basically I fork the thing, and then I did a make. So it's simple to use. Like you just clone it, and then I compiled the code. So I did a make, just make, and I was able to do it. And then you can run it. You have the binary, and then you can run it. The thing is, they show the instructions here. This is where I'm a little bit stuck on this Jetson, to run it from the Docker. So I have Docker running, but the problem is the image that you use needs to have the right CUDA version. So CUDA is something that you use for the GPU. So this came with CUDA 11, and it didn't work. So far I have not been able to run something from a container or from Docker to talk to the GPU, but I was able to enable Docker and Containerd with the GPU following the instructions from Nvidia. And it's a little container toolkit that you run and you enable it. But let me show a demo on GPU burn so you can verify that your GPU. So you can see now the GPU is 0%. So if I go to the GPU folder, I did a make, and then this is the tool. So if I run it for, I think the default is a few seconds. So if I run it, it's running for 10 seconds. If I switch back to the JTOP, where's the JTOP? You will see the GPU will start. Yeah, so it went to 99.9%. So it's really stressing the GPU. So this is how
You're
far I
inside
can.
the code, you're inside a container, Carlos,
Uh,
or this is your laptop?
no, this is where is it? This is I'm this VS Code is running on the Jetson, so I'm SSH into the Jetson. Everything you see here is on the a Linux machine, the Linux server.
Okay.
And then that's the problem that I have. This GPU burn uses CUDA, and I have CUDA set up in my host, in the Linux host. When I image the operating system, CUDA is working, and you can query it. So for example, if I go, there's another uh, project when you have one of these devices, or just CUDA. CUDA is just a framework to access the GPUs in Nvidia. So if you download this repo, GitHub Nvidia CUDA examples, then you can go to a program here, an utility that you can query the GPU with CUDA to validate that CUDA is actually working in your host operating system. But I'm not able to get it working from Docker. These images are not compatible. So I can even show the error that I was getting. Like um, it was using CUDA 11, and it says like it was looking for CUDA 12. I have CUDA 12. Um, and then let me show you CUDA samples first. So in here, I think it's under utilities, and it's called device query. So I compiled this code. Again, I did a make for makefile. So it's very useful if you know or learn make. So I was able to make this program, and then I can run device query, and then this device query would actually validate that you have the driver correctly and that CUDA toolkit is installed. So they call it a CUDA. Yeah, I guess it's a CUDA driver and runtime version. So I have 12.2. So any program or most of the programs that want to access the GPU for NVIDIA would use CUDA. So that you need to have the libraries and the driver for CUDA. So in this case, I can prove that my operating system works, that my GPU works, that I can exercise the GPU from the host operating system. And it gave you all the information about the GPU. So I was able to access the GPU through the kernel. And you can see here CUDA 12.2. So I'm getting very far. So the next step is finding a Docker image from NVIDIA that has CUDA that has CUDA and also all the libraries that you're trying to use. So, for example, I did the GPU burn. I'll say a few things about this, and then I'll jump to the actual book and then show a little bit of Knative.
So the Jetson board, what version of Linux is it running?
Oh, so they have two images. They have one with 22.04 and Ubuntu 20.4. The one that I install here is, let me see, I cannot remember OS.
UTC/UTC. Nope, no.
I don't know why I put a dot. Maybe because I was running a program, right? Yeah. On this one, what I decided to run, 22.04.
Oh, so perfectly normal. This is a perfectly normal. Okay. There's no
Yeah.
special Jetson version of Linux running.
Well, TBD. So this I didn't install Ubuntu from scratch. I flash any special Ubuntu, not a special, but a Ubuntu 22.04 that came from Nvidia, and inside has the correct drivers, the right packages, the libraries, like everything set up correctly. So that helped a lot. So that's why I was able to get stuff working on the host operating system. The next thing that I want to do is like get it in a container. So I can receive from Docker or from Kubernetes, and that's where I'm getting stuck. But yeah, looking information online and the forums, I was able to figure out a lot of things.
I see your point.
So I can use the GPU from the Linux operating system, but I cannot use the GPU for my container.
I see. So the vision is this box will become a node on a cluster.
Yes. So, I want to install Kubernetes and run it there.
Okay,
yeah.
Makes sense. Good luck with that. Good luck with that.
Yeah, as far as I got, I thought I was I had the exit coding here somewhere. This one also, I was also trying to see how to get PyTorch. What was the other thing? PyTorch. Yeah, this program here is a Python program. Yeah, PyTorch. I was trying to get PyTorch working, and I installed PyTorch from like the instructions online, everywhere that they say pip install Python torch, and it didn't work. So I wasted more time there. And then I figured out that I needed to download this PyTorch Python package version from Nvidia that has CUDA support. And then this 05 works, this 06 doesn't work. So I did a pip install of this PyTorch, and then I was able to run this this program with it. So a lot of things to tinker around and learn. Like I'm learning a lot as like trying to troubleshoot, and I taught a new Linux, but I'm learning on it, and also learning how to run these GPUs and frameworks. So PyTorch is another framework.
Maybe it's like a basic question, but this Jetson is running in the cloud, or is it in Nvidia hosted?
So
no, it's running in my
just a little gadget.
It's running in my desk here. Like this is my finger, right? It's sitting in my desk in my home.
Okay.
I have an Nvidia GPU server in my desk.
Do you have like Amazon link for it, like to order it?
Yeah. It's in the notes. I
Okay,
think Jack
thanks.
put the information. It's in the notes.
Yeah.
Yeah, they have different. I think the smallest price one is, I think it's called the Jetson Nano, very small memory, small GPU, and then you can go. This one is like the mid tier, and then there's one even more expensive one. But I got this one because was the 16 gig, because I wanted to play with like these large language models, and then I wanted like as much memory as possible. But yeah, the idea is that I want to access the GPU from my container, step one. So there's a lot. The way that works is, I can even show it, right? Um, Let me show you what I did. So this command here, I'm doing docker run. I don't know if people can see it. Docker run dash runtime Nvidia. So I was able to enable the Nvidia runtime in Docker engine and also in container D. But also you need to pass dash GPU all to it to run. If you run, and the reason that works is because I was let me put this. If you do cat, where's the location of the Docker daemon dot JSON? Somebody knows top of their head?
UTC Docker JSON?
No, somewhere
Var.
else. I think I wrote. This is the reason I created a repo with instructions. Because where did I? KS Nvidia. So I created this repo, and I have like, Jack and Safe, you were asking about the. So as my journey continues, I'm documenting for the next Carlos or myself if I come on next year what I did. So this is the and this is a GitHub repo I have. It's public. This is the board that I bought. Right, this is the hardware. I explain like the details that it has. It has 128, but I updated to 256. Then it comes with Jetpack 5, so I upgraded to Jetpack 6. So you have to upgrade that, but to upgrade that, it would be good to get a new memory stick. So I upgraded it's called flash, right, through USB. So I put the steps here on how to flash it with a new Jetpack 6, which is the latest version. And then I did my IP reservation, my SSH. I reviewed the kernel. So this is the kernel. It has a kernel 5.15. I check the command line, and this is where I was checking for if I need to update the C groups or not. But I think I have to, and that's it. And then for Docker, here it is. I installed Docker. So for some reason, Docker removed the instructions from the website to install Docker engine. So if you go to Docker, to install Docker on Linux, they give you Docker Desktop Linux, and I don't want Docker Desktop Linux. I want a Docker engine. So I put the instructions here for Ubuntu. Then to enable Docker so this is the toolkit I was talking about. So if you go to this toolkit, you install it, and then you have the CLI utility that would basically configure CRI-O, Docker, and containerd. So you run this command, NVIDIA Container Toolkit, the runtime that you want to configure, dash Docker, and I did it for containerd. So for containerd, I did it for containerd. And basically what it does is, and I can do it down here, right? It added this option, this extra argument, and it's telling Docker that if I run Docker run, if I run Docker run, I can do dash runtime equals NVIDIA, if I spell it correctly, and then Docker will use this instead. And then instead of using the Docker, actually like the client side, so this becomes the client. It's kind of an override. So I can run it like that, and then I'll be using this runtime. And what it's going to use is basically this program, right? This program is run C, but it's run C modified. This is run C. It's a modified run C to run a container, OCI container, but they insert the runtime to be able to access the GPU, so that you can access all the GPUs. And container D, the same thing. Like it will add the runtime, this runtime for Nvidia, and it will tell it to the binary name to run is Nvidia container runtime. So instead of using your typical run C program to run the container, instead run this binary, and then this is the binary that is compiled by Nvidia and provided by Nvidia that has support to access the CUDA and the GPUs. Does that make sense? I figured that out by myself because I didn't find documentation that explained this online. And then the next step is that they put online is like, if you do a Docker pull of this Nvidia runtime 12.2.2, it should run, but at least for me, it didn't run. So if I run this, this is where I got stuck, where I was installing PyTorch and Torch inside that container image, and then running this to collect the information, and it didn't work because I think some missing libraries are not compatible or something. So this is where I'm stuck. But if you want to help, or I can do a session, we can work together and pair program if somebody knows more about this stuff than me, or maybe Eric knows. Eric, you're Docker captain, you should know this stuff.
I am AI illiterate. But...
I think I got very far, right, Eric? As like Docker container knowledge.
Yeah, you're doing good. It's funny. I'm renewing my CKS today because I forgot to reschedule before yesterday, and this is one of the topics is runtimes, gvisor and stuff. So you're reminding me how badly I'm going to fail my exam today.
Oh, but for that one is it's switching the runtime to gvisor, if I remember, and then I'm running it with gvisor in the YAML. But yeah, it's all at the end of the day, all things run in containerd. Even Docker using containerd, right? And then containerd uses run C at the end of the day.
Yeah, they broke that up years ago.
Yep, yeah. But yeah, I think I'm getting stuck on the library things around like libc and those type of things. Like with this tool that I got here, GPU burn, I think I was able to build this container image, and then if I do docker images, I think I got GPU burn. So if I run docker run --rm what I said, runtime Nvidia --GPUs, and then you can say if you have multiple GPUs, you can tell it like which GPU do you want this program to have access to, GPU 0, 1, 2, 3, 4. If you have multiple GPUs, I only have one. Or you can say give it access to all GPUs, and then it might be because your program knows that it's going to take advantage of all your GPUs. So what was this command? All? I think it was all. All GPU -run. And I messed something up. GPUs. I think it's GPUs with an S. Yep, here it is. GPU run. What did I run? Docker images. I cannot spell. People are watching me. Docker images. Oh, GPU burn. Okay. GPU burn. Burn the GPU. So yeah, it says that it's using 12.2, the CUDA that I wanted to use. Actually, it got farther this time. It says init GPU test error, init GPU. The resource allocation failed. Last time I think is it GPUs all? anyway, see, this is the problem that I'm having. Yeah, GPUs all runtime Nvidia, and the program that I compiled with 12.2. So last time I was a libgc error. This time is a cannot allocate it. Maybe because I'm running the JStop. Anyway, that's for the GPU aspect on the Jetson. So the next thing I did was I was able to install in the book. Sergio has a chapter on serverless. I don't know if people can see this. It's very hard to see, I think. Let me make it like this big. So it has a chapter on Knative and cloud events. If you read the chapter, it explain what Knative is. One of the main features of Knative is a system that allows you to take APIs requests, HTTP requests, and it will go to a service. It will launch a pod in Kubernetes that is not running. It will scale from 0 to 1. That's most of the use case. And then serve that traffic. And if there's no more traffic coming in after short amount of time, or you can configure it, the pod will get deleted. And then so on and so on. So that's where like a little bit of the serverless aspect comes in. So I was able, so he shows how to install Knative, the KNCLI. I did it a little bit different. I used the tutorial and the KN Quick Start. So I went to the website of Knative and I did a tutorial. And basically the tutorial, what it is using a Quick Start. And this is a program that I created when I used to work, be a maintainer of Knative. And it uses Kind. So I installed Kind on the Jetson. I installed the KNCLI on the Jetson. I installed this CLI or binary called the Quick Start. It's a plugin. It's a CLI plugin for the KN command. And then I did this KN Quick Start Kind, and basically did a Kind cluster and installed Knative in it. So let's take a look on how that looks like. So I think have it here. So basically I have the KNCLI. And then there's this plugins called Quick Start. And I did that. I have a Kind cluster. So I did a KN Quick Start Kind. Quick Start -H. If you do KN Quick Start and you do Kind, it will create you a Kind cluster and install Knative service and eventing on it. If you do KN Quick Start Minikube, it will create a Minikube cluster, install Knative. I did the Kind. So I have Kind get clusters here. So there's one cluster called Knative. And then if I do I don't know if I have get pods -A, installs the basic Kubernetes here in Kube system, and then installs the Knative serving part component, which is independent from the Knative eventing part. So this will get you to the point in the book that you can run something with it. So I think the point to get to is to this one. I create an API, and then this says hello world. What port do you want to listen? What are the environment variables? And then revision. So let me see. I think I have that somewhere here. So I did it. You can create an API, or we can do the hello world. So let's do the hello world from the tutorial. So let me delete. If you do KN service, this is a easier than kubectl on creating YAML. So KN is a kind of a shortcut for you to see the access abstractions. So if you do Knative service, you can do Knative service list, I have to put this. Can people see this text okay, or should I make it bigger?
I can see it. I can see it.
Okay. So I created this a few hours ago. So let me delete it and then we'll create them. So service, I don't have autocomplete. So I go like this. And then I'm going to delete hello, right? So if I do get pods, I don't have any pods. So if I go to, and this is in the Jetson. So we show how to install K3s on the host operating system. You can use kubeadm to install Kubernetes. I find that for learning purposes, I love kind and creating kind clusters. So I don't know what other people think. I'm using it lately more and more to like develop things and as a platform engineer. So let's go to go ahead.
I said kind is my go-to usually as well.
Yeah, it used not to a few years ago, and lately it's there everywhere where I go. There's a kind example, and when I encounter a place where they don't have kind examples to get started, I usually go to Slack and talk to the project maintainers and like, hey, it'd be good if you have like a quick way of running your software with kind. Actually, that's what I was going to try with Volcano next week. See if I can run Volcano on kind. But anyway, Knative. So you want to use Knative? Yeah, the tutorial is very good. There's a bug. So there's this utility called func. It's like creating functions or help you create like functions. Basically it's it will give you the template with the language Go, Node.js, but on the JSON on ARM it doesn't work. So I open an issue so I can link to the issue. So I skipped that and I went to the Knative service, which was the one I created, and you can run this command. It basically says make it bigger. It says create a service called hello, uses the Docker image, container image, hello go. It listens on port 8080. So it's basically a web server. And then there's an environment variable inside that then returns back the message. So if we create this and we go to the terminal and paste it, it will create the service. So right now, the service is created and it's available in this URL. So you can just open a browser on this URL, or you can go to the next thing on it and then see the list that I got created. So you can do the list. So it got created and it's ready. So ready equals true. It's ready. And then the next thing is to execute it. So access the service. So you can go do a curl. But this is a good shortcut because you're running kn service describe hello -o URL, and then that will give you the URL that Knative knows how to shift traffic based on host name. So it's doing load balancing. And then do a kn service describe and then run it. So it's accessing this URL and then it's running. So I can just do a curl directly in here, right? If I can type correctly, right? It says hello world, hello world, hello world, hello world. And if I do get pods, there's a pod running. So this is the pod that is responding to that request. It wasn't there a minute ago, right? And then let me see what else. Yeah, basically, right, is there. And then if you do something like kubectl to watch that pod, I think it's 30 seconds or a minute.
It's up to 2 minutes.
Yeah, 2 minutes. You can switch. You can change it to be like 5 seconds. I think I usually when I used to do demos on Knative, I set it to 5 seconds. And then the Knative, the pod would just go down and be deleted. So we can check in 2 minutes from that. But just to show you some of the components inside is when there's no pod running, there needs to be some network traffic getting that request, holding that request, and then telling the deployment, because there's a deployment, get deploy, right? There's a deployment to scale it to 0. Oh, I think it went away already, right? Terminating. So yeah, it's terminating. And that component is called the activator. So the activator is a pod that receives this traffic. Actually, the first thing that receives the traffic, it could be Istio or Courier. The network interface. In this case, I installed this ingress gateway. This takes the traffic, it inspects the host name, and it knows where to send, what deployment to send it, what namespace to send it. Then this autoscaler will get that, the activator will get that HTTP request, hold it, because there's no deployments, then tell the autoscaler, hey, scale this deployment to 1 because there's much traffic. And then the autoscaler will set the deployment to a number higher than 0, and then the pod will start. And once the pod is ready, that's why it's very important to put liveness and readiness probes in your applications and your pods. Then when it's ready and there's an endpoint, then the activator will say, go ahead, send the request to that pod, and it will start sending. And if there's a lot of traffic to a certain degree, then the activator gets out of the way, and then all the traffic flows through from the network gateway directly to the pod. So that's just a short explanation of like how Knative works. Any questions? So in terms of applicability for our Jetson, right? I don't want to be running a lot of pods in this Jetson. So for example, I want to implement a pod that does inference, right? That runs a model, gets a prompt, and responds with a prompt. And one pod should be accessing the GPU at a time, for example. Or if I have a bunch of apps, I don't want to have all the apps running all the time, 24/7, if they're not being used and wasting resources. I want to shut them down on this little device. So but it makes sense to do in this way. Of course, if it's a stateful set pod with a database or something, that's when do you want to have it running all the time on the Jetson. Questions? Ideas? But I was impressed that everything worked on the Jetson. But again, like the GPU thing part is what's giving me trouble. So in the book, the author Sergio has the same examples. He creates a Knative service. He calls the Knative service. It shows the pods. The book is a very like tutorial based. It has you create another API. It calls the with curl inside, has different APIs, and I think it has. If you want to do it in YAML, then you can get the YAML. Let me see. Create API. You can get the YAML back if you want to show the YAML. I can show the YAML in a second. You can update the API, and that will create a new revision. You can also like do traffic splitting. So in here you can see. I don't know how to highlight. I cannot highlight. Why? I thought I was able to highlight. It's because I don't know. And here's, you can say split the traffic. So maybe you have a new version and an old version, and you can say send 50% traffic to the old version and the new version for this service. You can do that with Knative. He shows that example. And I think that's something with eventing. So eventing is there. He show how, the eventing pods are there, and it's running empty broker, eventing, IMC broker. So all these things are running. He has an application of implementing a simple event. It's an HTTP request that you send, and you handle a post. So he shows an example on how to run Knative, but the tutorials are very good if you want to follow also the book and also on another example. For eventing, here's the traffic splitting example that we were saying. I mean, we can run it if people want to see it. It will update the same service with a different variable. So I can run this. So now I have 2 revisions for the same service. So I have 2 versions. Not the and this the difference is not the image version or image tag. It's like one has one environment variable and the other one has a different environment variable. And then if you want to, you have to assign a new revision to this, accessing the new revision. Then this one says, instead of hello world, it says hello Knative. And then if you want to see the revisions, you can see it here. And you can see like this one is 100% of the traffic is the new one. So if you create a new revision and you don't specify the traffic, it will be 100% rollover. If you want to split it, then you can say update the service to be 50% to hello 00001 and the latest one, whatever is the latest one, to be 50%. So if you run this, now you will see, if we run it again, you see like 50-50 traffic. I think that's what it shows here. And then if you want to hit it over and over, now with the curl, where's the curl? It says hello world, hello world. It should say hello Knative, right? Hello Knative, hello world, hello Knative. So it depends. If you send a lot of requests over and over, roughly will be 50% hello world. Yeah, maybe eventing is homework. You can like play here if you want. But yeah, it works on Jetson Nano. Funk doesn't work, but Knative works. Yeah, and the book has examples. There has more examples if you want to play with it. Yeah, I think that's it. He has one serving, one eventing.
Okay, so I've studied Knative a while back. I read about it. It's serverless. It was sort of the Heroku model in Kubernetes. And I was like, okay, I can scale to 0 with this. Okay. Who uses Knative? What's their application for Knative? I just didn't understand it enough to know whether I needed to use it or not, because I have things that that mostly sit idle. I suppose I could scale them to 0, but I'd rather just let the pod be idle than learn the concepts of Knative, I guess.
It depends. Yeah, it depends. If you want to know more, we in the website we have. I think we put it case studies. Where is it? I think it's on there about case studies in here.
Yeah, I'm skimming through those. Yeah,
yeah.
I'm skimming through those. I'm
so
like, okay.
Deep C is around using eventing, right? It's not only about scale to 0, right? It's eventing, like processing event-driven applications, outfit, but also the concept of like the experience that I showed you right now.
Mm-hmm.
That 50% traffic, traffic splitting, even if you don't scale to 0. For someone that doesn't know Kubernetes at all, doesn't want to see a YAML file, you saw that I was able to, with this CLI, to be able to create an API, a URL with a container, and you didn't have to know it was Kubernetes. I don't have to tell you that it's Kubernetes, right?
Okay. So
people are building SaaS solutions like as a service, right? You log into a website and you say, here's my GitHub repo, go ahead and create me. Like you mentioned, like Heroku type of workloads. But yeah, if there's more, there's a good, interesting use cases here that are here. And then the blog post, also there's some blogs that show some examples on the different apps to use Knative. But at the end of the day, is another CRD. But yeah, I'll leave it at that. Thank you, Jack, for your question.
Okay.
But yeah, that's the coverage for today. I was able to get Knative. I wasn't able to get Funk, which is what I did a Funk create. This is the part that I did. I did Funk. Where was it in the tutorial? I did the function. So I created Funk in Go, but I can create it in any language that I want. So Go, Node, these are templates: Go, Node, Python, Quarkus, Rust, Spring Boot, TypeScript. And it depends what type of event do you want to handle, an HTTP or cloud events. This one is Flask. And it created me this folder here, which has a func.yaml, my hello, my handle.go. I think I can show it from here. It has a func.yaml that it only has this information. This is the YAML. Then it has what else is in this folder? Hello handle.go, your code. It could be Python or maybe I can create one with Python. And this is the Go code. And then you can do a func build, a func run, and it will handle the Docker. There's a Docker file behind the scenes that is used. Not Docker file, more of build pack. And they will build a container for you. I think there's some hidden files here. And this is kind of also a different experience that they have of like creating functions and that you get code. But this one didn't work on the JSON, on the Jetson. Okay, we'll leave it at that. I'll put the issue number or the issue link in the notes. And we'll let you in Slack to see if they fix it, the func. But everything else work out of the box on ARM64. So if you want to give it a try, give it a try. This works on Raspberry Pi. It's like it's ARM64. So it should work the same way.
Did you run any reference AI inference application? Did you run I saw you were trying to get PyTorch working. Did you run any reference? I assume that it runs really fast.
Yeah. I was able to run. Which one did I run that it would run very fast? Local AI. I was running local AI ran faster on this one than the Raspberry Pi. I think I flashed the.
Okay.
I think I flashed the image. I got it running, and then I reflashed the operating system and I blew it away. But yeah, Olama, and I know I tested local AI, and the answers were faster. I think it was one of the two. I cannot remember one of the two, but it was much faster than the Raspberry Pi.
Very good.
But from like I said, not from Docker, because those things you can run it from Docker, but because I'm trying to figure out how to get the Docker to run, and it depends on that image, right? What CUDA toolkit they have inside, what are the libraries, dynamic libraries that they have for glibc or libc. But if you're running on the host, then on the host it's using the GPU. I was able to run the GPU. I have an example. I know which one that I run. Was CUDA? Was not CUDA. It was hello. Where is it? K3s-based CUDA.yaml. Was an example on the Jetson webpage. This one. So this is the company that I got the Jetson board seat studio, and they have like a fine tuning. So you can do not the inference, but like the training of the model. So this one is doing fine tuning LLM by Llama Factory on Jetson. Llama Factory is kind of like a cool GUI that you select the model that you want to use, the data set that you want to use, and you can fetch it from Hugging Face. So this specific example is training this model on Chinese language to teach Chinese. And yeah, runs super fast, at least what I compare in here. And I was able to run it. Do I have it installed? I know I installed it and then I deleted everything. So I need to install it again. Let me see if it's
So it's like that, Carlos. They did like solution like QSGPT, like they gave it LLM and they gave it like a data set to train it on errors on what's wrong or happening in Kubernetes, for example.
Sorry.
Is it like that? They created a models like KSGPT, which like to debug Kubernetes, like they gave it a data set and they gave it a model to train it.
This specific example is using one of the models in Hugging Face, Llama, and training it with a specific data set. In this case, it was training it with Chinese. I think it was Chinese language. Let's see, it was Chinese language.
And depends on the data set, you can do whatever you like after that.
Yeah. Some models are good at different tasks based on what they're already trained on, and then when you're doing fine tuning, you're training on top of it even more specialized things. So this one wasn't using Llama. Sorry, it was using. I think the tool is called Llama Factory, but you can select the model that you want. It's a long list, 1.5, and then the data set that you want to train it. And like you said, if you want to train it in terms of Kubernetes knowledge to make it like a Kubernetes assistant, which is another project I'm working on, you can just give it the data set instead of being Chinese, documentation or things like that. You give it like the Kubernetes API spec and the Kubernetes blogs, and then your own Kubernetes runbooks, right? And that's more information. So that's, you can do fine tuning and you can do RAG augmentation with that. But yeah, it doesn't have to be Kubernetes. It could be anything. But this is just showing you that you have this in here to show you how to use something to use your Jetson GPU. So that's why I got the idea, the information about JTOP and making sure that the full GPU is being used when it's trained. But again, I would like to run it from a container, and I cannot find the
I
container
understand
yet.
what you're trying to do. The thing is,
Yep.
I'm understanding why they're making this. And people can't upgrade their existing PCs or their laptops to do this. They have to buy something new. And so Nvidia says, why don't you buy something from us? And so
well, this is not Nvidia. This is a third party, but Nvidia is making available like this SD. These are SD. These servers
Right.
are like development kits for people, for companies, like trying to do embedded devices or put AI on cars and things like that, or AI on retail stores. These boxes are good for that. But yeah, if you there's different. They have at least this company. There are many companies that sell it. You can find them you can buy them from Amazon. I bought it from Amazon, but they have the different computers here. The industrial one. This is the one I got. The J40 I got. The old versions, the J20. No, this is the industrial one. I got this one. This is the one I got. It's kind of a nuke. I got
that's kind of a
this
nook.
one. Yeah, I got this one. It does 100 tops. And it has a 1024 core Nvidia Ampere GPU with 32 Tensor cores. And the one that I got 8 cores. So that's why I was wondering, like, why I was seeing only 4 cores out of the 8 cores enable. So it was because I didn't enable the mode to use more power, like 25 watts of power instead of 15. And then the memory, I wanted like the one with 16 gigs. So that's the one I got. And I was glad that I was able, the SSD drive, you can update it. but yeah, I keep experimenting, but I'm happy with just using the GPU from the host, because a lot of the programs I see online and all these tutorials and examples, most of them run on the host, not on containers. But I'm just going to see if I can get at least one container running using the GPU.
Yes, very good, very good.
Okay. Well, thank you so much, everyone. I need to go, but thank you for joining. Like always, like some of you are joining every week, so hope this is useful and interesting for you, and you're learning some.
Interesting for
Yep.
me. Yes. Thank you very much.
Okay. See you, folks. Have a great weekend.